can simplify this just a little bit and make it 25x squared plus 25x plus c. And now that I've gotten to this point, I need to use this piece of information in order to solve for c. So I always need to have a point in order to solve for c, and a point from the original equation. So I would plug in 60 equals 25 times 1 squared plus 25 times 1 plus c. That would be 25, 25, 50 total. Subtracting from both sides would be 10, or just use numerical solve. But you get that c equals 10, which means that your final specific function is f of x equals 25x squared plus 25x plus 10. Box it and move on. All right, I would like for you to do the last two on your own. Remember that you can make that 2 down here, the t squared to the negative 2, so you can get out of the fraction. But I would like for you to do b on your own now. Finding x of t, we know it's x of t because this is our like y value, right? And this is our input. It becomes 10 times 1/4 x, sorry, not x, t to the 4th, plus 18 times t to the negative 1, and then divide by that, and then plus c. 10 times 1/4 can simplify down to 5/2 t to the 4th. Dividing by negative 1 makes this minus 18 over t, because that t to the negative 1 would go into the denominator, plus c. If you left that as t to the negative 1, totally fine. Now I need to solve for c, so I'm going to plug in 46 for x and plug in 2 for t. That's 40 minus 9, I think. So 31, and then subtracting 31 from both sides, I think would give us c equals 15. Or you could have used numerical solve. And then we get our final specific function is 5 over 2 t to the 4th minus 18 over t plus 15. Weird looking function, but that's what it is. All right, and do c on your own. Finding c of n, we get 100 times 1/3 n cubed minus 50 times 1/2 n squared plus 120 n plus c. I'm going to go ahead and plug in my point and simplify these coefficients at the same time. So I'm doing multiple things in one step. Hopefully we're following along, feeling okay about it. 355, plugging that in for our y value, equals 100 divided by 3 times 9 cubed minus 25, 50 times a half, 9 squared plus 120 times 9 plus c. Using your numerical solve, using your calculator, however you'd like to do it, we get that negative 23,000 equals c. Okay, so our final specific equation is again, not the nicest looking one, but it's what we have. So that's really the only new thing we're learning here. It can get obviously much more complicated than that, but we're going to practice that in class together. And we're just going to finish this last problem on the other side and call it a night. So it says a factory has modeled the marginal cost of production of sunglasses. Of producing sunglasses? I think that's supposed to be producing sunglasses. As C prime of n equals that. Okay. C prime of n represents the additional cost in US dollars for an additional pair of sunglasses, and n is the current production level of thousands of sunglasses per month. The factory is currently producing 1,000 pairs of sunglasses per month at a cost of 50,000 US dollars. So trying to build our instincts here, what I thought when I first read through this was, okay, prime, so that means it's the derivative. So if we're trying to find, we're probably going to be finding the original function. So, okay, I need to find the integral. It gives me units, which is important. We will see why today. With this example. And then it gives me this information. The factory is currently producing 1,000 pairs of sunglasses at a cost of this. And so that is a point, right? So hopefully there is something in your brain that was like, I think that's a point, and it is. And we're going to need that point in order to solve for the C of our equation. And so that's kind of what all of these sentences are communicating to you is here's your function, prime. Okay, interesting. We're finding the integral. Your units of measurement, which is going to be important, and then a point for the original, which will help us find the C. So it says to write down the units for the antiderivative function C of n. And so in order to find those units, we multiply what our y value is for this guy, what C prime is, divided by the unit of measurement for C prime multiplied by the x value, in other words, n. So C prime of n represents the additional cost in US dollars for an additional pair of sunglasses. So it's US dollars over pair of sunglasses. And we multiply it by our x value, our x unit of measurement. And it says that n is the current production level of sunglasses, thousands of sunglasses per month. And so this is why this is important, is because then your unit of measurement for your derivative, the sunglasses cancel out, right? And this is just sunglasses, not necessarily pairs of sunglasses. The sunglasses cancel out, and yes, we're left with US dollars, but we're left with thousands of US dollars. So your unit of measurement for your cost is in the thousands. And so if your Y is 50,000, what you're actually going to be plugging in for that point is 50, not 50,000. So since we know that it's going to be thousands of US dollars, it alters what number we plug into our equation in order to solve. So that's why it's important to know is that might not have been, some of us might have just been like, oh, it's just US dollars. It's actually technically thousands of US dollars. And so it's important to keep that in mind. And it's why this process is important. And that's why most IB questions will ask you to do this first if it is important. So it says find the function for the cost in thousands of US dollars for producing thousands of sunglasses per month. Because remember that our X unit of measurement stays the same. Our X unit of measurement stays the same. So it's still going to be thousands for our X values as well. So 1,000 pair of sunglasses is actually going to be 1 for our X value and then 50 for our Y value. So finding that function, we want to find the integral of C prime of n dn. We are going to do 45 times n cubed and then divide by that new exponent minus 130 times n squared 1 over 2 plus 80n plus c. I'm going to go ahead and plug in this point that we saw from above and solve for C. I would like for you to solve for C on your own. Plugging in 50 equals 45 divided by 3 is 15 times 1 cubed minus 130 divided by 2 is 65 times 1 squared plus 80 times 1 plus C. We end up getting that 20 is equal to C. We can put it all back together. Our integral of this function, the cost in thousands is going to be 15n cubed minus 65n squared plus 80n plus 20. Okay. It then says to find the minimum total production cost and the corresponding production level. So it doesn't tell us specifically how to do this. It doesn't say to use the production cost, nor does it say to use the derivative of that. But I am going to use the derivative. I'm going to set my derivative equal to 0. So plugging in that derivative into the equation, 45x squared minus 130x plus 80. We get a parabola that looks like this. And we are setting this equal to 0. We're trying to find where it's equal to 0. And we see that there's 2 places where it's equal to 0. This is where it's important to be able to just kind of quickly think about what our sign diagram says and what it means. If I just trace on TI Nspire, it immediately locks into intercepts. So that was the y-intercept right there. Here's our first 0. It says 0. This is a really weird way to say it, but this is also saying 0. It's just a really, really, really small decimal, close enough to 0. And then that's our x-intercept, our first one. And then our next one's at 2, 0. And then we can see that our derivative is above the x-axis. So it's positive here, and then negative, and then positive. So looking at this, realizing that if it was positive, that means that your original function was increasing and then it was decreasing. So this is a maximum, whereas 2 would be your minimum, right? So when it says find the minimum total production cost, we are actually caring about this intercept and not the other one. So that's why it's important to be able to distinguish what's going on your derivative. So since n equals 2 is where your minimum occurs, we just need to find the production level, the production cost. So that means that we need to do C of 2. Go ahead and find C of 2. Plugging in 2 to your function that we found up above, you should get 40,000. You get 40, which is in thousands, so it's 40,000 US dollars. And that is it. That's this whole set of notes. Good job.